Let's discuss two problems, Leetcode 1 and 15, two sum and three sum. Before we discuss, please share, like, subscribe and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. I want this website, this channel rather, to become the most comprehensive computer science channel. So please consider subscribing, and I will be adding a lot of quizzes every daily basis. So now back to the problem. Let us discuss two sum first. You are given a vector and a target. So you need to check if there are two numbers which add up to the target. The vector is not sorted actually, the inputs vector, but in this case it is sorted, but the requirement is it is not sorted. In that case, you could have used like two-pointer approach to minimize the make it more efficient if it is sorted. So because it is not sorted, you use an unordered map to see at each level whether at each number you want to see whether there is the difference, you get the difference between the target and the number. So at 2, if for the first one you just add it directly to the map because that is the first one, but at 7 you see when it is 7, hey, you know 7 and you know 9 at all at each stage. So you just get the needed number and check if the needed number is there or not. So in this case, when the index is at 7, the needed number is 9 minus 7, which is 2, and then check whether 2 is there in the map. It is, and so you can return the index 0 and index 1, and that is and you are done. So that's why I called it as a needed number in map pattern. So you go through the input vector, you get the current number, and then you get the needed number, which is target minus current number, and then check if the target number is in the map or not. If it is in the map, and in this case you return the indices of both of them. Otherwise, you have to do this anyways, right? Because unless you return, you have to keep whatever number you saw. You need to say, hey, 7 has been found at index 1, 2 has been found at index 0, like that you need to store so that you can process them here. And that's it for two sum. Now moving to three sum, which is slightly different. There is no target here. The target is actually implicit and it is 0 basically. And so now here you use the two-pointer method. So because of that, you need to sort the numbers, and I call this pattern as like let me give an example. Like in this case, right, -4, -1. This is already sorted actually. The input list is not sorted. So this one I'm showing after this execution. So like you need to find a triplet like -1, -1, 2, which equals to 0. So for that, I call it as like for two pointers pattern because there is a for loop for the first one, and then within the for loop you have a two pointer function. So that's why the name the pattern. And so here another requirement is you cannot have duplicate indices to duplicate triplets, basically, not indices, duplicate triplets. So if you have -1, -1, 2, then you cannot have -1, -2 again. So that's why you need to check if I -1 is not equals to I. That means there is no duplicate, and then you can go into this two-pointer method. Within the two-pointer method, you start off low is I plus 1, high is the last number, and while low is less than high, now you get the threesome here. So number I from the for loop, and then low and high from the 2-pointer approach. If it is less than 0, so now you know you need to, because they are sorted, you need to increase the low to make sure, hey, we might actually get to 0. Or if it is greater than 0, then you reduce the high so that you might get to 0. Otherwise, in the third case, it is equals to 0. So at that point, you push the result into the vector. But because of lack of duplicates, you need to do low plus plus and high minus minus. And also, if you want to check whether low is less than high, nums low is less than nums low minus 1, same check what you did here. To make sure you want to eliminate duplicates again, you do plus plus low. And I have run this case. So if you can see -4, and then -4 is the for loop is at this stage, and then low comes I plus 1, and then high is here. So that's why you pick -4, -2, -3. So you keep on because the value is less than 0, you keep incrementing low to see if you can get to 0, but finally you could not get to 0. The max you could get up to is -1. So then in that case, the for loop goes to -1, and then immediately right off the bat you find out the triplet. And once you found the triplet, now you have to move both low plus plus and high minus minus. So that's why -1 moves to 0, and 2 moves to 1, and then you do one more triplet. -1, the for loop is here, -1, so -1, and then 0, and then 1, you found another triplet. And once again you increasing low to high until low equals to high, and you get out. So that's why you found 2 triplets which equals to 0. And that's it. Let me know if you have any comments. Otherwise, I will see you in the next video. Bye.